Okay, we will get started here. Again, welcome to Apply Day. Um, Before we dive in, I just want to give a quick background of applied engineering. For over 35 years, Applied has been helping companies overcome their engineering challenges, whether it be with our technology team providing training, implementation, or support for software and hardware solutions, or our services team providing design and manufacturing engineering, as well as software development and reprographics. We fit your needs. With that, I will turn things over to our presenters.
All right, thank you, Emily. I just wanted to give a big thank you to Applied as we get started here today. We've been partnering together and your team's been amazing at solving problems and helping customers of ours that needed your solutions. And we're excited to go over streamlining manufacturing with advanced CAM. And so I've got two people that are joining me here that are deep experts in their field. Stan Akers is a power mill expert and has a whole career built around this industry, and he's very fantastic. You're going to enjoy hearing him. He's going to be doing a short demonstration in here. The other is Andy Barney, and he's going to be showing feature cam. He also has a ton of experience. As you might imagine, these guys have been in this business so long. Andy, I think you've built your own CNC in your garage in addition to having worked on them and performed on some of the most difficult machines in the industry. So the three of us are going to go through this with you. And so if you've been with Applied for a while, you may not be aware of us, but we are NexGenCAM, and we've been Autodesk's CAM partner, their top partner for 5 of the last 6 years. We're an authorized training center for them, and we do a whole host of services just around CAM. And we have a very highly experienced team. If you look at our full team on the technical side is 14 people, and all of them have experience running CNC equipment, and they have experience with the Autodesk CAM solutions, and most of them have experience with non-Autodesk CAM solutions as well. We have a nationwide sales and customer success team, and we also have a couple of different brands where we get into NexGen Robot, which is getting a robot arm to work as a CNC machine, so putting a milling head on the end of it and going crazy. And then the Programming Plus name, which is more around doing programming services for clients. So you're probably wondering, who are we and what kind of a reputation do we have? Here's a company named Hastrader Industries. It's just been a fantastic partner with us. We did a success story with them late last year, and they have the distinction of having recently won this award where they've been labeled one of the top 10 CNC machining industry service companies. And when we started working with them a number of years ago, they came in and they had this challenge for us. The challenge was we want to get into aerospace and defense, and we don't have the proper tools and skills to do that. So we helped them to invest in the Autodesk CAM solutions, and you can see the result here is that they were able to accomplish their goals for advanced parts, and they've been growing, and especially in 5-axis machining, which you all know can be more difficult than the simpler milling processes. And we've kind of grown to be great partners, and I think we just ran into them at an event last week, and it's just kind of like connecting with old friends. Here's another comment from Randy, and another customer who we've been helping actually with 3 different solutions in the Autodesk portfolio, all of them at the higher end of the capability in the CAM industry. So you could take a look at this. You could even go further, and you could say, okay, well, that's what you're saying. A few people said you can go onto the Autodesk Services Marketplace. You can see we have another 35 reviews that are peer reviewed by Autodesk, where we have gotten excellent results. So here's what we're going to go over. We've kind of gone over just our expertise and the capability of our team. We're going to go through the milling solutions on the expert end of that, have a demonstration of Power Mill. Then we're going to go over the automated programming capabilities of FeatureCAM and a demonstration. We're going to review some of our high-end capabilities in advanced turning, and go over Fusion 360, which is one of the hottest CAM solutions on the market, which we've been working with since its inception 4 to 5 years ago. So when we get into high-end milling and we're thinking aerospace and auto and folks that are doing very complex parts, you start to encounter greater complexity. You start to look for how can I get better control. You can't imagine how many customers have called us when they weren't customers and said, I can't machine this part. I don't have enough control. I don't have flexibility in the software to maneuver the machine to do that. And new technology, as things change, the machine tool vendors are coming out with new technologies and adding new things and capabilities, always trying to help you to have more capability in your business. And then there's increased precision. How do I get higher tolerances? How do I get in the high-end medical fields to achieve certain surface finishes and things like that? End users are constantly investing also in new machines. So while you might have started initially with one type of machine, you get customers that say, well, can you do something more complex or more difficult? And these are the challenges in this industry. And there's a skills gap that a lot of people are saying that does or does not exist, which is how can we get people confident? You look at that part there on the right-hand side and you think, wow, how could I cut something that complex and not make an error? Well, you need good software. You need to simulate it. You need to prepare for it. You've got to take a big problem and break it down into smaller pieces. You know, how do we also get performance? So it's one thing to have a part on your machine and it takes a long time to cut it. So how many of those can you do? At what point are you making money or not making money? And how much manual rework can you afford to have into your operation? These are the kind of considerations that we have, and that's why Autodesk has added in PowerMill as the premier expert solution for multi-axis milling and high-speed milling. And so you just look at the capabilities. It's doing high-speed, very good at 2D milling, 3+2 machining. So when you're doing a 5-axis machining, but just moving 2 of the parts, you know, getting into full 5-axis machining, mill turn, robotics, and automation. We have some customers that are leveraging the automation engine and are greatly reducing their workload by taking repetitive tasks like doing a dovetail or something else and bringing that through the system and automating it so you don't have to do all the little tasks and you can focus in on what is that new neat thing that I need to do in this space that must be done really well. I talked a little bit about robotics and our robotics capability. It's kind of a niche space here, but it's a really fun space to be able to take a robot and do some of the CNC capabilities that you're familiar with, and also to do other things. I think we've done things like sanding and other repetitive tasks that are difficult for people to do. But this is the full solution here for PowerMill. A couple of things we want to highlight today is toolpath optimization. With PowerMill, you have the ability to really get into the nitty-gritty and to dive in and figure out how am I going to get exactly what I want out of this programming. You're going to see that in more depth as Stan goes into it when he digs into his presentation. We talk about 5-axis optimization and getting control and using analysis tools to figure out what's actually going to happen when I hit the green button. It gives a lot of our customers comfort to know that we've got a solution that's really very flexible and is able to work in these difficult situations. We talked about customization and automation. I know when I first got into the PowerMill side of things and was looking at what we're doing and some of the automation macros, I thought macros and toolbars, that sounded kind of simplistic, but it's actually a very intelligent way that this has been put together, and it's really pretty simple in a sense that you could do the work the way you're normally doing the work, and then what you do is you take the things that are solid steps that you do repetitively and you build those into a toolbar so that the next part that comes in, this isn't some sort of automation that only works on the exact same part, but it's something that's going to work on all the different types of parts that you come in, and you choose the parts of the automation that you want to work with. And that's how we're helping get people a high productivity. Here's a slide that Stan and I put together and to think about what is it that programmers are doing day to day in their time. Some people think, oh, they're just sitting around programming all day, and we know that that isn't true. You know, there's a lot of time spent in the shop. There's a lot of time in meetings where you've got to meet with engineering or your customer, or figuring out what types of materials will work for different scenarios, working with the QA team and trying to figure out what's going on there. And you literally don't have as much programming time as you think. So we're trying to focus on automation and put these building blocks in so that we can really help folks. Stan helped out with a project where we had a customer. We reduced their programming time over 80% of the course of 2 to 3 months working together with them in the consumer product space. Here's another customer and what they're saying and working with PowerMill. And I really like this comment in the middle where they brought in some Herms, fantastic CNC machines, and they needed CAM that was capable of driving that amazing machine. You know, you think about if you were driving a Ferrari, you wouldn't want to drive a Ferrari around the block in only first gear. You'd want to get it up into the higher end gears and the capabilities of your machine. And I really like this. They're saying days were saved due to fewer setups and shorter machining times. I know we've done some comparisons where we may have someone bring us a program and say it's just taking too long, and we're able to put it in here, and it's a dramatic reduction in the lines of code, in the capabilities and the surface finishes that come out. Here's another customer, and then I'm going to hand it over to Stan to dig into the software for a little bit and show you just a taste of what we've got going on here. This is another customer where they're dealing with difficult meshes and shapes, and you see they're getting into very artistic things that are difficult to do. And I like this. It says, hey, without PowerShape and PowerMill, PowerShape is a companion tool that goes with PowerMill, we wouldn't be able to do the work that we do here. And I think that's a great quote that describes what these expert solutions are capable of. So at this point, I'm going to stop sharing, and I'm going to hand over to Stan Akers to present.
Sure thing. Let's see if I can show my screen here.
Yeah, Stan, I'm always jealous. I just get to talk to slides, but you get to show the fun stuff. So have at it.
Oh, yeah. Okay, so taking a look real fast at PowerMill and just giving a brief overview, as Eric was stating, with complex manufacturing solutions and CAM products, what you want to look at first and foremost is a nice streamlined design that can take the user through the experience easily, because you're talking about a solution that has to give you so many tool sets in one package. So just to start out, when you see PowerMill for the first time, you can kind of see how it's kind of working from left to right throughout our ribbon interface, but it kind of is broken down into all our process solutions, and PowerMill can give our users capabilities within each of these panels within the ribbon interface to be able to set up and control just about anything about your part within your environment that you're manufacturing. So particularly within the 5-axis range with PowerMill's, one of PowerMill's greater abilities, we have these capabilities based off of your setups, based off of your structure, and you can see in our Explorer interface how this is kind of lined out to help your users organize things through PowerMill. That also goes into, the creation of tools that you might need, which PowerMill can support just about everything for. And then, of course, our industry-leading Toolpath capabilities, starting with material removal within several roughing capabilities that you might be looking for within the industry into 2D. And of course, our 3D toolpaths, which every single 3D toolpath within PowerMill is completely capable of going full 5-axis. From there, within a process in advanced manufacturing, you're looking at verification as being one of those leading things. And with an active toolpath over here, we can see on the left-hand side of my toolpaths, over here where my mouse is in my tree, you can see that the toolpaths have kind of an indicator next to them, kind of giving the user the idea of the safety of our toolpath. So as we reach into 5-axis in machining, one of the things that is of great concern is keeping the equipment safe as well as the parts in the process, especially on something as large as a mold. in 5-axis. So if I take a look at our first kind of indicator for verification within PowerMill, I can click on a single button and your users are automatically put into this verification mode where we can just simply click on an error and see that it outlined our errors in red. And it'll actually take the tool straight to that area for verification. From here, the user can make a couple of decisions. They can either delete those areas out or split them, or they can actually go into a more advanced setting of verification and be able to use different tools to create blends within the split and a distance over that blended area. So you have complete control over that split difference between the bad and the good side of the toolpath. So I'm gonna go ahead and apply that. And what PowerMill will do is go ahead and split those into 2 different toolpaths. I'll get a safe toolpath with the stubby, smaller tool here. And then I'll also get the toolpath that still has collisions with it. Now, once that's been made, we can go into what we call the PowerMill process. So we have kind of 2 different toolpaths that we've come up with the split of the 2 toolpaths. And of course, you can see now our safety indicator on our blue toolpath. That's green. You can see that leads and links within the toolpath have all updated automatically within there to kind of help streamline the process and keep the tool within clean range. And we can also take a look at both of these strategies at the same time. You can see there's a blend between the 2. Focusing on the error toolpath, you can see that I have a red exclamation mark, first indication that we've got some problems there. And then I can go into maybe adjusting this toolpath to suit my needs. So again, I can go into my advanced verification options here. Instead of splitting my toolpath, maybe what I'll do is just replace my tool with something a little bit longer. And then I can take that section and just apply that with a longer tool. Let that calculate. Once it's resolved and no collisions were found, we could do a quick gouge check on this as well to be sure that it's gouge free. You see now we have 2 safe toolpaths. Now, the next step within the process of the PowerMill way, we call it, is once we have a toolpath created and calculated, we can go into toolpaths in PowerMill and just quickly restructure or organize things without having to recalculate the toolpath. And one of the best features in PowerMill are our toolpath editing capabilities. So if I select a series of toolpaths on my project, I can go into my reorder structure and I can tell PowerMill to just simply automatic reorder and maybe reverse that direction. And it will go through the process of restructuring and reversing all those toolpaths. And of course, reapplying leads and links all the way through that as it goes through the recalculation of it, all without having to go into the toolpath itself and doing any kind of recalculation or lengthy recalculation of all of the options inside of the toolpath. It's all done within a quick edit of the toolpath. Further into that, I also have the capability of completely redoing the leads and links of a toolpath at any point in time. So if I go into that toolpath's leads and links as a edit, you can see I can come into my lead in, lead out here, and I could say restructure some of the lead in, lead outs if I want to, or even the links in this case. I could say instead of an on surface length on a lot of that, I could give it a smaller constraint and maybe push it to a skim so that it moves outside of the part. And we no longer have those moves wrapping up and around the part. We can also do the same thing with our lead ins and lead outs. I could simply just select individual lead in, lead outs, go into my lead ins and lead outs, and maybe say, let's do a extended move for this and extend that move out. All the selected, just simply apply those individual leads and you get the change right away as you calculate through. You don't even have to go back into the toolpath and recalculate. I can do the same thing for the lead outs, apply that over to the other lead out, and you'll see the adjustment take place right at the toolpath level. Of course, you can always do all of this stuff in the toolpath itself as an automation. If I go into my settings of my toolpath, give the pause, there we go. Just open the settings of the inside of the toolpath here. You have all the capabilities to be able to tailor make the toolpath to do everything that you need to do on calculation, including the automatic verification of a toolpath. So if I just tick on automatic collision avoidance here, give it a holder clearance and a shank clearance, this toolpath will calculate with this tool so that it will automatically verify itself and there'll be no collisions and you'll have a perfectly safe, nice, clean toolpath. From here, we go into more of our simulation side of things and our 5-axis side of things. If I double click on another toolpath here, you can kind of see we have a 5-axis toolpath kind of set up. If I simulate this toolpath, let's take a look at the machine tool. as part of our verification. PowerMill has complete capability to control your machine tool verification within the applications itself. This is not an external verification of any kind. If I just simply simulate this toolpath with a right-click function there, you'll see that it's going to attach the tool, move the machine kinematics where necessary, and I have complete visual control over the machine throughout the process. Now, if we take a look at our 5-axis capabilities within PowerMill, one of the things about complex 5-axis is having complete control over how that toolpath is going to reach these angles and these vectors within that machine tool. We have our tool axis control capabilities within PowerMill. I simply recycle my toolpath there and take a look at these. You can see we can control our toolpath many different ways from different geometries, such as lines and points, or we can use our lead lean technology capability, which basically controls the projection and the tangency of the tool to the surfaces based on angles, either by the contact normal of the surface or vertical from the toolpath. We can also do this as an automatic verification as well. Now, if we look at this within simulation, one of the things we could look at is control over the approach to the work itself. Now, this is something that's very important when we get into more complex 5-axis solutions. If I right-click on this toolpath and simulate it, you'll see that the toolpath kind of approaches directly straight down on the part. One thing we can do inside of PowerMill is with one of our toolpath edit capabilities, we can come in and we could just say, move that start point to a more feasible location just by applying an absolute start point and maybe making it something like 800 thou, or let's go 5 inches in Z. And then we'll apply the absolute movement here as well. If I apply both of those moves, now you'll see that the toolpath is now starting and approaching the work from the left-hand side of the part versus just straight over the part, maybe avoiding scaring the operator within the process of the setup, coming straight over the part itself. Now, PowerMill's capabilities, of course, can do this for any 5-axis machine. We look at this through the aerospace industry on large head work. You can kind of see I have a toolpath on a part here in a very large machine tool. This machine tool has some structure control that we have to have over, say, how the motion of this machine simulates. And if I simulate this toolpath, we'll start to see how that moves and rotates around the part. I'll speed that up a little bit. And as it moves around, we have some areas where maybe the head isn't quite clocked or timed in the right location. Well, we can simply come into PowerMill and come into one of our toolpath edit options, go into our dynamic machine control. Now we can either rotate and pivot the machine head however we want to at this point, or we can also just swap the configuration on the start so that the head of the machine starts in the correct location, and all based off of a graphical user interface that guides the user through these processes. There's no heavy drop downs that you have to go into or any tick boxes that you have to turn on to be able to do any of these capabilities. They're all based on what you want to do at the cut at the time within the toolpath. And once those edits are applied, the toolpath doesn't need to recalculate. It simply changes those vectors and that technology within the tool axis that we saw on the fly, all within an edit. And PowerMill's capabilities are able to do this through 5-axis technology as well as robots. As we can see here within our simulation, if I rewind the simulation and take a play on it, we can just kind of see the robot move. We have complete control over all 7 axes on this robot itself. And then also in the field of additive technology, not just removal for toolpaths, we also have additive toolpath capability. But perhaps one of the best features PowerMill has is within its ability to automate all of these processes. If we take a look at another example that I have here, you just see our part here with our fixture and our tool all in one place. But within the user interface of PowerMill, what we're capable of doing is actually breaking down automation by recording macros and then replaying these macros within a user interface based on preset buttons. If you see if my demos tab here up in my ribbon interface here, if we go through this from the left-hand side, I have tools here that help me apply a machine template to bring in, maybe save or import models, then maybe organize those files. As I go through these tools over on the right-hand side, I'll just skip to the very nice part of this demonstration. You'll see if I hit the record button, how these macros can be structured to record. It's just a simple process of whatever I click or whatever I decide to do, each command in PowerMill has the capability of recording. So we go through the structure of recording a complete toolpath. We can actually come through and do things such as our setup processes. And I'll just select this part here, just quickly put a block around it for stock. Maybe I want to go through a step-by-step instruction to be able to set up the work plane for this part. Well, I can click a single button and my users can be set to go through that automation step-by-step, where they want to place that, as well as how they want to orient it, and what the name might be. So once my work plane is set up, I can recalculate my stock. And then from there, with a simple click of a button, I can apply multiple toolpaths within the automation from those macros that are recorded. Just by clicking my roughing technology here, you'll see PowerMill will start to load tools and toolpaths and go through these calculations all with one button push. We'll let that calculate real quick, and then as that applies, that it's applying the roughing, the rest roughing, and the stock models capable to do the rest roughing technology. So hopefully I was able to stay in my time limit here. Let that calculate through. And with that, that's just about all I had to show for the time I had.
That's great, Stan. Yeah, it's good to see it just simulating some of that and going through it. It's powerful when you can do that in a couple of clicks as opposed to doing it manually.
All right. Yeah, this is going through the calculation a little slower, probably due to the go-to meeting, taking the graphics up here, but it'll be done shortly here. But all with one button click, I've managed to rough 5 different toolpaths and then apply stock models to each of those roughing technologies. And this capability allows you to free up the rest of your time as a CNC programmer to focus on more difficult parts of the machining process, or even to apply this before a meeting. If you have a very large project to calculate this over, maybe you go and you apply this, go to a meeting. Once you've done with the calculation, you can go through and view and simulate the toolpaths, or you can come through and edit the toolpaths as needed. So again, part of the PowerMill process, calculate something successfully, come in. If you see something you don't like, we can even just delete it. And the process recalculates without that toolpath segment. So with that, Eric, that's about all the time I had. I will pass it back over to you.
Yeah, thank you, Stan. That was great. And you know, one of the things too, when it's calculating, I just helped a customer upgrade from an older version of PowerMill recently. You can actually run 2 instances now, right, or multiple instances, so that right, you can have the calculations running on one screen while the other instance you're doing work on another project. Can you guys see my screen?
Yeah.
All right, so we're going to shift gears a little bit and move over to the FeatureCAM solution and go through it. And we really dig into programming times. How can I take the easy stuff in my shop and just get that stuff done as easily as possible? When we talk to a lot of clients, they're spending just as much time on the easy work as the hard work. And then you start thinking about the shop as you add new machines and you bring new things in. How do you handle that increasing complexity or different types of machines? You want to have a platform. Also, how do you deal with productivity and complexity across your whole team? So one of the great things I like about FeatureCAM is you can kind of teach it and train it to program like your best programmer and help everyone come up to speed in a job shop environment or a production environment. It's a very powerful thing. So if you look at FeatureCAM, what it does, obviously it does a whole variety of milling. It also adds in wire EDM. And then for production, it's got tombstone, multiple fixtures, and a whole host of things that are capable over there. And then it gets into the multitasking for turn mill and getting into Swiss type lathes and doing turning, obviously the simple turning, and then some probing on that side of it. So this kind of rounds up all the capabilities. It's kind of a Swiss Army knife that can do a lot of different things in your shop. And so I just want to go through this. You know, when you're starting to program a part, you just go through these steps that you normally would, which is setting up the part and doing all these different manual tasks, selecting the tool, selecting different parameters and things that you want to set. And then you simulate the process, and then you finally generate your NC code. And that's the typical process people are going through on a frequent basis. One of the things that FeatureCAM is doing is it's recognizing the features, and it's saying, hey, a lot of this stuff could be automated. So let's go ahead and automate this stuff and just go directly through, identify the features, and program something amazingly quick. Now, that's what Andy's going to go through in a minute, and it's probably better just to see it more than anything to see what's going on. You can also see that Autodesk is developing a lot of interactivity between the different products. So FeatureCAM and PowerMill and Fusion, there's a lot of things that are being developed kind of simultaneously to add comfort and familiarity across the products. Here's an example of another customer, and I don't even have to go through this whole story. I mean, you just look at it here, and complex prototyping for aerospace, and parts are being delivered 80% faster. Setups are being reduced 10 down to 1, and there's more time to work on the hard things that need to be done. Getting rid of all the easy stuff really quickly, and empowering a shop to be more performant. So with that, I'm going to hand it over to Andy Barney, and master of all things FeatureCAM. I will make you the presenter here, Andy. There you go.
All right, welcome everyone. Hopefully you can hear me okay. Eric, does it sound good?
Sound is good.
All right, so I'm going to take you through this. Eric kind of stole the term I like to use for FeatureCAM. It's the Swiss Army knife. It does everything, whether that's 2D milling, 3D milling, 5-axis positioning, simultaneous, turn mill, just simple turn, wire EDM, etc. Okay, so one of the things I want to focus on is similarities between FeatureCAM and PowerMill. They're both ribbon interfaced, so we have the same type of idea. We can work through our workflow working with the ribbon, so it looks very familiar in that sense. This is actually the workflow to do a part, so for a new user, if they were not sure what to do next, they could check here and see what they want to do. But when we create things, we're going to see results in our part view and over here on the right side. So the toolbox is on the left and the results are on the right. And then in the middle, we have our good graphics window, and we're going to go ahead and start doing this. So I have a solid model. So FeatureCAM's claim to things is reduced programming time, ease of use. Basically, if we're not cutting the parts, nobody's making money except for the programmer. So if a programmer's still programming the parts, he's making money, but the shop isn't making money producing the parts. So we want to get rid of that. So in this case, I have a part file, and I also have fixturing to represent things that I can collision check. Now, it doesn't do the collision checking the same way as PowerMill, but it does actually look for collisions. So if we see them, we'll be able to identify those and deal with them. Okay, so one of the things we have is one of our steps is basically to create features using automatic feature recognition. And that's where I want to focus. In this day and age, most people have a solid model to work with. If you don't, you can use traditional CAD tools to draw your parts. But if you have a solid model, you're going to be light years ahead of the game. So I'm going to run automatic feature recognition on this. I'm going to go into all the details of what's happening. But I have one setup on this file that's represented here, and it's going to look at this model and extract parts or features, excuse me. So when I press next and take a few seconds is all this takes, it's identified all the features on this part, and they're represented by that dark blue. So you can see there's a face, a hole. In fact, there's 91 holes, and then some milling features. Okay, so when I hit finish to this, if you look to the left, you'll see under the setup, there's nothing here now. There's nothing over here in the results window. When I hit finish, FeatureCAM has automated all this. It extracted the features, and a feature is a shape. Okay, so whether that's a hole, a counterboard hole, a tap hole, a pocket, an open side area, chamfer, whatever those might be, those are shapes that we're trying to machine. And FeatureCAM created all of those features, okay? But more importantly, look at all this over here. Here's the results of this. It's actually selected tooling that works. It's calculated the feeds and speeds based on the material that I have for my stock and what the tool is made out of. And it uses a table to do that. All of this is customizable to your use, to your preferences, but it also has done step overs and depth of cuts and all these other things. So for example, if I look at this milling feature right here, and I go to the roughing and look at the step overs, it's calculated as step over. Now the way this does this is using customized settings. So if I go to the features and manufacturing area and look at my machining attributes, these are the active settings that are in this document. Okay, so when I'm doing milling or drilling, or what are my lead and ramp settings or whatever, these all come into play, whether I'm in milling, turning, or even wire EDM. And so then when we get into turn mill or something, that's a combination of turn settings and mill settings. So there are settings. Here's where the step over came from. It's 1/3 of the tool diameter. This is not something you have to stick with. You can customize this to be whatever you desire. And that comes in the form of configurations. And if you look in here, when I open this, you'll see several of these have a little paper icon. Well, I have several file examples I'm going to show you open, and these are machining attributes that are in effect for the active document. I can actually customize settings for step overs, depth of cuts, pecking, tool selection, all kinds of different things for mill, turn, whatever, based on the machine and the material I'm using. The feeds and speeds are not handled in here. They're handled in a separate table, and I'll show you that in a minute. But I can customize settings based on what it is that I'm trying to machine. So if we have aluminum on a Doosan machine, maybe we've got a really big Doosan machine that's a lot more rigid than our, say, a Haas tool room mill. We're going to have different step overs and stuff. So if you take a little bit of time to pre-configure this, when you start a brand new file, you get to choose what set of settings you want to load into the document. Those then become the attributes for that file. Then the active tool crib is what FeatureCAM chooses from to select tools. So I have, in this case, I've got a very vast tool library that came installed with the software. If I switch it to a tool crib that has tools that don't make sense for the job, in fact, this part is metric, this crib does not have any metric tooling. So if I were to show you the dimensions of this hole, it's a 10 millimeter hole, that's the conversion. There's no 10 millimeter drill in an inch only tool crib. So you see how it did it. And I just simply swap out to another tool crib and you see how the intelligence that the FeatureCAM works with, okay? So by having this, if you think about it, how long did it take me to run this? And maybe 80% of it is what you want to keep. So we can simulate in a simple wireframe. If you watch the arrow moving down here, showing you exactly where you are in the process. It's ordering things automatically. We can manually order things if we want by entering manual ordering mode. We have all the control we need here, but it extracted all these features and machined it. However, this mode of simulation doesn't collision check. But if I run a 3D or a machine simulation where we see the machine, kind of like what Stan showed, if I have any collisions, FeatureCAM is going to prompt me. In fact, I expect one here shortly. Okay, so right here I have a material or a gouge issue. It says the tool may have gouged or wrapped it in material. If I look closely, it selected a center drill that's a little bit too big to fit in that area. So even though it selected it automatically, it didn't, in this case, take into account this wall, no big deal. I can see exactly where I am in the process. I can highlight it. I can double click it. This is a pattern of 87 holes, so I only have to change this tool one time. I hit apply and update, and all of these have an asterisk showing that I made a manual change. The software is never allowed to change that, only a human being can. So it takes human interaction to ever change that. That's locked in. If I resimulate, let me slow it down just a little bit so you can get a little better view of this. You'll see that we now clear the simulation through there. We no longer have the collision and we can move on. Now I'm actually showing the fixturing. The fixturing will also be used for collision checking. So I've set it as fixturing, or a clamp, we call it in the software. And if anything hits that fixturing, whether it's a shank the tool itself or the holder, I would get a collision. Now in this case, I probably won't have any more collisions. You see we're working through the process as we go through, so I'll go ahead and speed it up a little more. And if we make it all the way through without any collisions, we're already at the point where I can view my NC code. Simply clicking on the tab right here, and here's the NC code based on whatever post processor I have loaded. And in this case, I'm using a Haas 5-axis, even though this isn't a 5-axis part. But I can just simply swap out the post processor, resimulate and generate new code, save the posted code, and go load it in the machine and go. So there are some maybe slight things you might want to change, but if you think about the actual amount of time it took me to program this part, at least get the bulk of it done, I'm way ahead of everybody else. And in fact, I might make a few tool changes. I might maybe change a step over. I might, even change a way I machine an area. Maybe this area I want to machine differently. I can do that and change that, but I'm not spending all my time on the easy stuff, right? Okay, so moving on to that, because this is advanced cam, I want to talk about something both Power Mill and Feature Cam have, and it's called Vortex. And so Vortex is one of our roughing strategies using solid carbide tooling. You want to set the cutter really deep and do the adaptive toolpath strategies. So if I were to take a look at this one right here, you'll see it calculate. I'm just going to preview this toolpath, and we're going to see the toolpath, the tool entry, and then the trochoidal moves only in the corners where we have the vortex strategy kicking in. Okay, and so you can do that with solid carbide tooling and do all that. Now, in the interest of also talking about shared technology, Feature Cam also does surface milling and 5-axis work, as I mentioned, and it's actually using things based on Power Mill's algorithms. So I have a few examples in here of strategy here where I've done a combination where I'm doing a Z level, that's for the steep areas, and I'm doing a spiral type of motion on the flat areas, and we're going to see where that is. So I'm going to just go ahead and preview this toolpath for you, just so you get an idea, and then kind of explain to you some of the differences between how Feature Cam does this and how Power Mill does this. Okay, so Feature Cam has the same toolpath algorithms. The difference being it doesn't have all the bells and whistles that Stan showed you with the draw box and relink it and all that stuff. That's not here, but if you do some surface milling, the stuff in Feature Cam is very, very capable of doing multiple strategies. And in most cases, they are also 5-axis capable, as Stan mentioned. In fact, I'm going to go look at some settings here in a moment, and you'll be able to see similar type of things. So several similar controls. So it's the advanced toolpath editing that Power Mill offers that is different from here. But if you don't need all that stuff, Feature Cam is more than capable of doing it. So if I turn on this document and make it a 5-axis document, which it's currently just set to 3-axis, and go look at one of these toolpaths, you'll see that I have 5-axis control. In fact, one of the items that Stan showed you were these other methods, and he showed you a few of these from point to point and all these good things. And I'll just show you how I can just simply enter into 5-axis mode, telling my tool axis to rotate over that point. It's the same tool path other than we're in 5-axis instead of 3. So it recalculates, and you'll see that we have a brand new tool path with 5-axis motion. And so Feature Cam can do all of that as well. It just doesn't have the toolpath editing, but it does so many other things besides just milling. And we're going to look at that here in just a minute with the turn mill side of things. So if you have the multitasking machines, like a Morisiki or Mazak or a Haas with live tooling, whatever that is, you can see those in the other things. And so if we look at this, if I catch this right, you can see now as I slow this down, it's now a 5-axis toolpath rotating around that point to machine the same area. And it was simple as having a point in space. I just created a geometry point, placed it out where I wanted to rotate around, and assigned it to the toolpath, and it now became a 5-axis toolpath. So if we look at all the different processes, these are all the surface milling toolpaths that are available. There's one missing right here that if you were in a 4-axis document, it'd have a rotary. You can see all the different finishing and specialized strategies and all the things. So FeatureCAM is very capable of doing everything. As I mentioned, it's the Swiss Army knife, right? And it can combine strategies using a steep and shallow, where we do a Z level with the steep stuff, and choose either a raster or parallel type of toolpath, or 3D spiral for the flat areas, and limit it with a slope angle or a threshold limit, and do that. Okay, so moving on into turn mill. Okay, so here's an example of a part. All the turning is done on here, and that was actually done, everything but this cutoff I did with AFR. And I basically said, hey, let's program this. I have 2 setups, one on the main, one on the sub. So I have one on each end. I want you to program both. It'll actually try to do milling and turning. So you see it's got a bore feature right here. It also gives me the option of drilling that out as a hole feature, so I can keep one or the other or both facing the end of the part. A hole in the flange there and there. And then side feature, if I wanted to mill the flange with the side of the tool. The depth is a little bit interesting, but I do have one and I can adjust it, and my turning. So that's what I did. I kept just the turning, and then I added in a cutoff, and I'm transferring the part to the sub spindle, telling it to grab it, move it this far, pull the part out, cut it off, do all that. So it's handling that cutoff while supported by the sub spindle. And so what I wanted to show you guys was just another form of feature recognition that FeatureCAM has for the milling stuff on this, okay? So you'll notice when I did this, the Z-axis were the only direction any milling happened. It didn't do any of these holes or this flat out here. So I could simply say, hey, I want to mill this flat, but I want to, click here, but I want to stay in between that surface and that surface. That's ultimately what I want to do. So I'm going to do a feature that'll do that. I'm going to use interactive feature recognition, and I'm going to say, hey, I want you to do that around the index axis. And depending on the type of feature I select, I get these options, right? So what I'm going to do is I'm going to tell it to take my tool axis, basically point the tool towards that face, and let's see what we can machine. So I could try automatically determining that, and you can see right here, and here's a preview of what it already selected. I said I'll keep both of those. I have that. It's done the same thing FeatureCAM does everywhere else. Picked a tool that fits, looking at the radius, that's any radius restrictions. It's set depth of cut, step overs, feeds and speeds. You can see all that stuff here. You can adjust it if you want, but it's already programmed it. So then I could, maybe do a slot right here and go, let's slot this out using feature rec. I'm going to say normal to this face again right there, and select the faces and just add them into my list to have the software look at the model. It's going to look at it. It's going to create the feature. If I want to change the top or bottom, I can. I'll take it just a little deeper to make sure I clean up, drop it down in there, hit finish, and I got a tool path, a rough pass, a finish pass, or I can do a simple option where it takes the 10mm tool to match the width and just does the ramping and cuts it out like a slot. So all these controls. Then doing my holes, same thing. I can go hole, extract with feature rec, find the ones that are along the setup Z. So this one, and this one, if I want them. Find them, the ones that line up, give me all the different kinds. I can say I want them all, or no, I don't want that. Just deselect it, hit finish, selects tools, feeds and speeds, pecking, all that good stuff. And then lastly, I'll do the holes around the OD. And so you see, it's really easy using a solid model to be able to automatically detect features and do that. Now, when you get to a part like this, that was all the milling that I needed to do minus this flange. And so I'm going to pick this one and show you this one. Just simply do this real quick, do a boss feature. That's kind of the opposite of a pocket. I'm going to have it go normal to, oh, whoops, I want along the setup Z, sorry. So along the setup Z, I'm going to say use this surface that I have selected. and then you'll see the top and bottom because I selected the bottom face as no idea what I really want, so I can use this to correct it. So I can say, no, the top is here, and that was only because of where I picked, and the bottom is there, and they say, hey, let's go another millimeter deep, extra 40 thousandths, make sure we clean up, and off we go. Feature Cam does the rest, right? And again, reminder, this is because of the feeds and speeds, or excuse me, the machining attributes that are active in the file. That's determining what's happening in all these features, okay? So the feeds and speeds table is happened here. This a bunch of dozens of materials come installed with Feature Cam. You can tweak these as you desire, and you should. When you're doing turning work and you have a carbide tool, this is your surface millimeter or surface feet per minute if you're an inch document. Roughing for like OD work, ID work, and so on. If we go to milling, same idea. Contouring or profiling, slotting, facing, surface feet per minute or surface meters per minute, depending on what document type you're in. And if you switch to a high-speed steel tool, it's obviously going to need a lower value. These tables are pre-configured. You should tweak them to what you want and customize them very much like you would have custom settings for the type of machining you're doing for the rest of that. You have all that worked out, and Feature Cam makes your life just so much easier. You get the parts out of the machine, and so on and so forth. And lastly, synchronization. This is an example, just in the interest of time. This part's been synchronized. I have some work happening on the upper turret, lower turret. That's sub spindle. It's color coded. This is main spindle. I have opposing holes drilling at the same time. We can run a machine simulation in 5-axis, 3-axis, whatever. I'm going to have to open my holders up. Ignore these for a minute. We'll just go with it. But if we have any collisions here, we'll see that as well, which I expect we probably will. But you can see the work. And so the first time through, it's actually running an empty on the sub. And then you'll see the transfer if we make it through without any collisions, which we have one right there. So I need to extend that drill. Then it would do the transfer and do the work, and we'd have the NC code based on our part. So that's Feature Cam in a nutshell. Hopefully you can see an overview of how it does really good at checking things for you. It's a really smart and intuitive software, and it really walks you through the process on everything. So appreciate your time. I'll turn it back over to Eric.
All right, thanks, Andy. Definitely, there's a lot to look at there, but we did it in kind of a compressed amount of time, so it's just a taste of the full capability that we've got. And so I'm trying to make myself the presenter. Let's see. There we go. So one thing we didn't cover was Swiss style machining, and we have full support for Swiss style machining. And then also you can just look at the tremendous amount of post processors were built. I think it's over 1,000 now of these that we have built up with all these different machine types. And Emily, I wanted to ask you if we have any questions. I can definitely go a little faster. There's a lot of turning capabilities in here in function.
We do not have any questions in chat.
Okay. Then I will just summarize, all of these solutions come with Fusion 360, which is an integrated design and CAM package. And so that it's something that you have the ability to do the CAM here, also with the expert level solutions. And, at the end, we're kind of a service-based company. These are some of the types of services that we offer. We've talked about them earlier. You can obviously get a hold of your applied team to learn more about working together with us. We have quite a few classes, and we also do a best practices class for every product each month. And I would say with that, we wanted to just thank you for listening today, and hopefully you saw something here that would be interesting to make an improvement in your shop or in your CNC operations.